Hello, everyone. Welcome to day 2 of the Cloud Advantage Virtual Summit. We're very excited to have you here today. And I am Laura Pursley. I'm the Senior Marketing Director with US Signal. I am very excited today to welcome Rebecca Weekly, the VP of Infrastructure Engineering from GEICO. And she is going to share with us GEICO's cloud journey. So welcome, Rebecca. We're very excited to have you here today.
Thank you so much, Laura. It's so great to be here with you. I'm going to talk a little bit today about our cloud journey and really cloud by design. So, how to think through your open source strategy, how to think through the underlying layers of that so that you can get the best outcome from making a change in your hybrid cloud strategy. Uh, I will start out with the adorable gecko because all presentations for GEICO should start with the adorable gecko, and also with a little bit of a background of GEICO from a business and infrastructure lens, just so you have some context of what we're talking about in terms of size and scope. So GEICO is well known for our car insurance, for our gecko, for our caveman, for lots of different things. But we're also the third largest auto insurer. We also have a lot of different things that we underwrite and also provide in terms of insurance products. We have 30,000 associates. And those are the people who actually make it possible for us to make lives better by protecting people against unexpected events while saving them money and providing outstanding customer service. GEICO Tech specifically runs many different domains in the open source and in the cloud space. And so I'm going to start to kind of give you a journey of our cloud infrastructure story. And I have to go back before I can go forward to where we are today and what we're doing about our design. So if you go back in time to 2013, we were 100% on-prem. All of GEICO technology was run within our 6 data centers, and that was our primary footprint for managing anything and everything across our 350 physical sites that support our different associates and contractors. In 2014, our leadership team decided we're going to the cloud. It's going to make us more agile. It's going to make us more capable. It's going to allow our developers to do more with their business. And so we went for it. Well, fast forward to 2020, we'd gotten about 80% to the cloud. So about 80% of our workloads were running in the cloud. And we were using 8 different clouds. 5 of the world's top IaaS providers were amongst those clouds. We were consuming about 200,000 cores within those cloud environments, 30,000 VMs within the cloud and container instances. And many of the containers were actually running within VMs. So a huge number of instances across 8 different clouds, data spread all over the place, 200,000 cores under management, just in the cloud environment. So that led us to a position where we really needed to contemplate, do we want to do this? Why do we want to do this? Where and how? And unfortunately, what we had found in this cloud environment that we were operating within is that it was costing us 3x what we had been spending before. And we actually hadn't unlocked developer efficiency. We hadn't actually started the process to get the right outcomes for our developers and our use cases. And so given that, we decided, hey, wait, why are we spending more to get less? Let's be logical about what we do on-prem. Let's be logical about what we do in the cloud. And let's really have a strategic engagement. So we decided to repatriate some things. We decided to modernize within our clouds. We decided to consolidate within our having 6 on-prem data centers timeline of solve problems with identity. We have 14 different flows that are still dependent on on-prem servers. We didn't solve the challenges that were actually making our cloud less productive. We got to modernize the whole thing. So we started that in 2023. And we really started looking at our hardware solutions, how we modernized our data centers, where we wanted to go in terms of co-location facilities, what kind of systems we wanted, how to measure and test those systems, what was working, what wasn't working, how we wanted to redesign our network solution, what our options in that domain might be, and really starting to ramp and deliver our new data centers with various systems. And you'll see on here, we had availability issues, we had challenges with delivery dates on systems, we had thermal issues, all the fun things that happen when you operate in the world of hardware. But ultimately, it really enabled us to build out our new data centers, bring up our new data centers, and begin this process of migrating out of the legacy system. So at this point, we have 6 data centers is where we started. We've left 2 of them. We are leaving more of them over the next 3 quarters. And that is enabling us to move to these modern data centers with the ability to phase up or down our requirements, including power, if we end up hosting systems that are much higher power, like GPUs, or lower power solutions, more comp density kinds of solutions, which is where a lot of our workloads are today. So if I really think through how and when and where we started the journey from a software perspective, it was actually to think through, well, actually, I'll finish this, right? We talked about bringing up the data centers throughout the course of this year, finishing out those last data centers that were exiting of the owned and operated legacy data centers, and really moving forward to all of our completion of our different migrations across the 350 physical sites. So it's a long journey. It's going to take us, again, we started in May of 2023, and it is going to be March of 2027, assuming we have all the trains leaving the station on time, which, hopefully will happen, for us to actually hit the full modernization of our physical infrastructure flow. But we actually came to talk about what we're doing to enable our developers today. So while doing the Lego moves on-prem, that doesn't mean you stop supporting your customers. Those customers started with 8 clouds. Those customers started with a lot of interesting design, kind of a hub and spoke model for a cloud network, backhauling traffic for security and inspection reasons, and a point-to-point IP model. That wasn't going to scale for our developers in the cloud, and they don't want to wait while we move things on-prem. So we really wanted to look at the cloud-specific portion of our strategy as well as our physical infrastructure. So what did we found when we did this cloud migration in 2023? We were sitting there and we had rising cloud costs 3 times higher. We weren't unlocking the newest technology. In fact, you really have to get them to extend, and it extends your RI timeline. And so if your RIs, your reserved instances, are 3-year timelines and they're launching new product every 2 years, you're always behind in trying to lock in a good price from what the newest, latest, and greatest technology could deliver to you. And then finally, we weren't seeing developers getting faster time to market out of this environment. Again, because issues around our automation, issues around solutions that we hadn't yet exposed to developers. I mean, lots of things for us. It's not inherently that the cloud is bad, but how we went to the cloud was overly restrictive, and it was not using best time to market strategies or solutions. We lifted and shifted a lot of older technology from on-prem to the cloud. That's not necessarily going to be the best process and path to go forward to give you efficiency. So I mentioned the cost structures. I won't spend too much time on the cost structures, and I certainly won't justify the left part of this axis, but to say it was far more expensive, and having the repatriation, this assumes a stable load. So obviously we will actually see growth over a period of time, but just by being able to support that load in fewer clouds on modern data centers, we are able to greatly reduce our overall expense over time. And so that's why we decided this was the journey we wanted to be on. So starting a hybrid cloud strategy is all about alignment. There's no way that I can move or change things that are running the core business when I don't support the customers directly. I support my application developers, who then support the business directly, who then support our customers. So with those 3 levels of indirect, I got to make sure everything that I am doing and the impact that it has to my customers is understood. So first off, model it out, try and really understand the impact of the business, and try to make sure we have alignment around the strategy and approach. And that will take however long it takes. You need to work with all of your stakeholders to make sure you're on the right plan. Number 2, you got to make sure you have the right people. So if you're operating a legacy data center using vendor managed tools, that's a different skill set than if you are managing open source software. It's not better or worse, it's just different, and you got to make sure you have the right skills on the team. upskilling the team, and bringing in good talent to help manage that overall flow. Next, you got to identify your anchor services and your overall data strategy. I can move and improve our network, but if all of our data sits in one cloud and all of our AI processing sits in a different cloud or on-prem, I'm not solving any problems because you cannot train a model without data. So we have to look holistically at where the data is, where it is going to be stored over the next 2 to 3 years, and how we can collectively make sure we are looking at cost, our actual security, the latency of the experience to the end users, and our overall strategy for, is this existential? Is it interesting? Is it differentiated? And so we want to use it versus, hey, this is a service that somebody else offers and it seems like it's pretty good and it's super low latency. Let's use it there. We really need to anchor in on the value proposition between those two, four technically domains. So really looking at those anchor services, which clouds they're in, or which environments they need to be in because of latency to an end user, and where our data to support them lives. And then you can start to decide what the infrastructure strategy underneath it can be. Number 4 is really driving technology decisions for hybrid migration and onboarding. What do I really mean by that? What I mean is nobody is going to wait to develop their application for a platform that isn't yet there, right? That's probably not a good idea for the business. So you have to find a good methodology for saying, here's what we're building. It's beautiful. It's amazing. It's rainbows and cupcakes and sunshine. But if you don't have it now and you need it now, here's how you can get started. Here's what we will do to support you from that to the next phase. And then they can come on to the overall platform over time. And so you don't slow them down. You don't become a gatekeeper. You become an enabler of their long-term success. That is hard to do. It takes a lot of prioritization and communication, but that is really what you have to get to, is an agreement. You align on the strategy and approach. You have to align on the overall operationalization, it's not a word, of that strategy and approach, so that people can move quickly, but you can also see the value of a hybrid cloud strategy, so that you have that, tension between go faster, vendor lock-in, go a little slower, work together, and you can communicate, okay, go fast. We'll figure out how to bring you back on in the next iteration. At least that would be my recommendation. And finally, timelines, clear milestones, clear goals. There's so many layers moving. If you're changing the physical layer, if you're changing the logical layer in terms of the cloud that it is operating upon, that's both a physical and logical. If you're changing platforms that they're operating with, if you're changing mechanisms of how it actually is used by an end user, there's so many dependencies in that chain. If you are not really clear about every miss, every hiccup along the way, and what it means for them, or let them at least understand what it means for them, you will never be successful. And the projects that have worked well are the ones where we've been incredibly transparent and upfront, and the projects where we've had hiccups are the ones where we haven't, for whatever reason, fully mapped those dependencies, really had the right operation process to flow that through to end users. So I mentioned map the technology, start with the technology. I fundamentally believe start with your developers. I would also say start with your business. That was the anchor tenant portion of it, and we'll talk about this. But if you're talking specifically about your hybrid stack, the people you have to sell are your developers. What do they want? What are the tools they need? Audit, compliance, identity and access management, data tagging, so that there's proper, attribution for cost, billing and metering, but also for identity, access, response, just in time, incident response, any of these factors. Typical environments are going to involve databases and messaging and caching and storage of various varieties, possibly workflow automation, most likely serverless of some variety, and certainly the ability to egress traffic in a higher level versus built into something fundamentally exposed to your developers. And what you want to do is are addressed in a timely fashion in accordance with the SLA that you have provided to your audit team without having to think about it by using managed services versus having to do and manage all of these themselves. You know, here's an example of the ones that we can use in terms of open source projects to support that effort. And then how do you map that across your infrastructure? Well, whether it's public cloud or whether it's GEICO's private cloud, having a common methodology across Kubernetes, on-prem using something like OpenStack from a fleet management perspective, using something like Ceph for object storage, and it certainly can be used for object storage. It also absolutely is used for file and block. Those are going to look different in a legacy environment of what you're supporting and what you're supporting for net new development, but really looking at those components and trying to understand where are we now, where are we trying to go, how can we maximize our flexibility? And you could use totally different solutions here and have great outcomes. It's not about which projects we chose to engage upon. It's about understanding what do those users need, and then how do we expose those such that it can go across our different cloud vendors and on-prem providers. So that was about how we kind of thought through our open source strategy and where we wanted to start from a developer and those developers in support of the business applications they're trying to build. For our cloud footprint, even though we had 8 different clouds, we had several specific clouds, one in particular that had most of our understanding, most of our actual cloud footprint. So it was about 200,000 cores in just this cloud and over 100 different instance types. So what did we really try to do to figure out how to turn that into a fleet for a repatriation effort? We really tried to start with memory and compute ratios. Every cloud instance has a memory compute ratio, and map that into a nice set of primary SKUs. It has a certain guaranteed amount of gigabits per second that are allocated to that particular instance, but that doesn't really talk about load. And that doesn't really talk about the effective load and how you're going to scale that in an on-prem footprint. So network nearly as often as you touch other solutions. And so it seemed like the right option was to over-provision network based on initial analysis without better data to really give us a sense of the active load on the network. So we started with our cloud footprint at our biggest providers. There we go. But when I say start with your network, or when I say talk about mapping your cloud, you have to map your cloud of remote offices, smaller offices, franchisee kinds of offices that have network connectivity. You have branch offices that have significant connectivity and possibly network or possibly servers as well. You have branch offices. You have different folks who are working in a remote fashion and using a remote access capability like a VPN, and how older networks might have been stitched together to support all these different solutions. An MPLS cloud, which was done to ensure that all data was actually brought back to a main hub, right? As if we were all always working in the office together, and that is the right location for all that data to go. So if you start having this kind of an environment, you're going to have a lot of latency because you have one hop to your branch office, one hop to your carrier neutral facility, your transit hub effectively, and then one hop to a proxy, and then one hop out to the internet. That's a lot. And you're not going to do anything very quickly for your users if that's the path you're taking to the cloud. So whether you're repatriating from, whether you're going to the cloud, you have to fix this. This is never going to be a good experience for users to be able to have a cloud use case. This is one of our key findings in our modernization is you must fix your network. If you are actually backhauling all of your traffic to one site or to a dual site strategy, that is not a good plan for having a good user experience. You may also find that you have some fascinating legacy network solutions. Many different companies used separate L2, L3 solutions, had all sorts of appliances within different domains, causing a lot of risk and fragility to their edge networks. And so if you find something like this, you have the opportunity to clean it up. Again, a transit hub isn't going to look like a multi-pod, solution over here on the right, but really trying to think through how you do your data centers in a modern set of flat network, high bandwidth across, so that you have as much bandwidth in the TOR as you do across the spine or close to it, is going to lead to a much better outcome for operating a network to meet the needs of developers running in containerized kinds of workloads, modern development stacks versus the gobbledygook on the left, which is not ideal. You also really need to look at your cost structures. So when you use an instance in the cloud, right, you're using an instance, you're possibly also buying licensing on top of that instance. You're also possibly on a much older instance, so not necessarily getting the best performance out of that instance. So this model is not necessarily true for anyone else. This is very specific to our environment and what we saw. But looking at our major public cloud provider and what we were paying for that 200,000 set of cores versus our legacy design and development flow for it, which by the way was significantly cheaper, as I said before, 3x to be in public cloud versus what we had been running on-prem, versus to run in a modern data center footprint with modern hardware. This is just an amortized model to show that there's a lot of really great hardware out there that is much more cost efficient, much more energy efficient, much more manageable. So there was a time when you had to buy an OEM system, everyone was going to have one, solution for if you purchased from OEM Foo, one solution if you purchase from OEM Bar, and God forbid you tried to operate across those two, you got locked into one vendor. But there's been a huge amount of work that has happened in the industry to standardize our management planes, to use open source solutions in these domains, whether that's OpenBMC, whether that's open from a fleet management point of view, like OpenStack. These are, or just Kubernetes operating on bare metal with a methodology for actually provisioning the asset, which could be Ansible or anything as simple as that. But those solutions are so much richer than they were in the past. And that's where you really start to see this, bending down of the curve. To operate on-prem is so much easier and so much cheaper than it used to be when people were looking at these solutions. So once you have mapped your cloud, once you've gotten your developers on board that they want to do good work, once you are starting to really engage and start building both a better experience for your developers on top of their public cloud and a better experience within your actual ecosystem, then that's when you start to drive your roadmap and take that little path forward. And there will be hiccups and there will be lots of challenges along the way. That's just the reality of doing anything in the world that is physical. It's also true of anything in the world that is logical. But we really found this was an incredibly impactful journey for us as developers. I want to make sure I spend a little time focused on what our key learnings were so that maybe that can be helpful to all of you. Never underestimate the value of having the right team. Good people, great tools. And I put that in the same category because if you don't have the right observability, if you don't have the right capabilities for automation available, you could have great people and they'll still be fighting blind. So you need the right team with the right tooling to be able to deliver anything to your business in this domain. You should plan that any kind of massive rehaul of infrastructure is going to be a 2-year roadmap, possibly 3. I described just shy of 3 to do the full ecosystem of all 350 physical sites. Don't assume that your hardware and your software come together, right? If you're going towards an ODM model or even an OEM, part of going towards an open source ecosystem is to control your own destiny, and it is to decouple these things. So you can make your purchases in the hardware space, you can make your purchases in the software space in a managed open source or directly from open source and supporting it yourself. They don't necessarily then validate on top of each other. So if you're coming from an OEM world where everything is ISVs and the value proposition of an Oracle database is that it will always run on anything that's in their listed set of hardware, their listed set of ISV partners, that is one of the values of that ISV solution. When you choose to go open source, when you choose to go with a more open methodology, you have to validate that those things work together. And that is a burden of responsibility that takes real effort, and you cannot assume it's going to be done for you. So to that point, you have to have detailed requirements. The number of assumptions and ways you can get off track if you don't have detailed requirements, both to your vendors that you're working with in the hardware side, but also within your partner layers across. I might think I'm ready to go because I've stood up OpenStack and I've stood up these components and I can validate that images are in the Glance repository and great. Do I have the dashboards from an observability perspective that my customers need to see? Have I ensured that all the alerting that people need to see across the ecosystem that we are supporting, both our private network connections to our public cloud providers, as well as our network observability within that domain, are visible? If not, I'm not done. And that process is a level of rigor that is easy to forget. It's easy to say, I'm good, it compiles, it works. But the entry and exit criteria between the various layers is critical. And one can never underestimate the value of detailed requirements. They'll be wrong, everything is wrong, but at least it gives you a directional set of core components you are looking towards to ensure that you can sign off on the next level. Open is not so open. I think open is great from a software perspective. You know what open means, right? You have access to the repository. You can be a contributor into that repository. That doesn't necessarily mean all the bells and whistles that you want for compliance, security, etc., are in that domain. And it's often a reason why people go towards managed open source so that they have the ability to contribute to actually do their work, but can take advantage of some of the value of the ISV already has done this work for audit, compliance, etc. But open is also not so open on the hardware side. So just because something is an open design and follows an open design spec, don't assume that means everybody's done it the same way, right? Trust but verify. So if it is an OpenBMC repo, go look at the repos. There's a lot of them. What version are they working on? What actual version do you need to have supported in your ecosystem? All of the different subcomponents that could be impacted is often underestimated in terms of the validation effort that it can take to bring up these systems in this kind of an ecosystem. And it's, again, one of the values of going towards an OEM versus working with an ODM and working in a more open source firmware kind of environment. If you don't have time to do that, you can purchase it. And you can purchase it taking advantage of some of the best design points. So a lot of the OEMs now do offer OCP compliant, so following best practices of hyperscalers, but within a more managed ecosystem, just like a managed open source, provider that like a managed open source, like Red Hat from an operating system perspective. These are options to control your own destiny, have more control, but still take advantage of their expertise in certain domains. And that may be a better choice for you than going all in on full open. So finally, I just wanted to say there's, a lot of different opportunities for us. We're hiring lots of people. So if you are interested, please do scan the QR code and come work with us. We are doing a lot of cool stuff in the open source space. We're doing a lot of cool stuff within the hardware space. And we would love to work with you.
Thank you so much, Rebecca. That was wonderful. And thank you for sharing your cloud journey with all of us. And the gecko is a crowd favorite, I'm sure. So thank you for including that in your presentation. Excellent job. We appreciate you taking the time.
Thank you.
And we invite everyone to join us at the next session, which starts shortly, about the global cloud landscape.